Hi everybody, I'm Dr. Burns and I just wanted to welcome you to ME 124, the Materials and Mechanics Lab. So for today what I want to do is go through our agenda for our first week. So within this here we're going to take a look at our syllabus, go over the course schedule, see how our homeworks and assignments align, take a look at the labs and talk about the grading policies. I'll be using Blackboard as a primary source of communication throughout this entire course. Your labs will be also viewed on Microsoft Teams as well if you're doing the remote option. We're going to talk a little bit about the COVID-19 safety in labs. This becomes very important, especially when we need to break our lab sections into a couple different groups so we keep the capacity and our social distancing to the right specifications. And with that, we're going to talk a little bit about lab safety. I'll be posting some lab safety videos as well to Blackboard. So, description of the course. What we're going to do here is we're going to introduce experimentation, engineering measurements, data analysis in solid mechanics, instrumentation for dynamic measurements, photoelasticity, mechanical testing, and heat treatments of engineering materials. So this is a rough overview of what we'll be looking at this semester. I'll get into some more details with each of the 6 labs that we'll be performing. Your prerequisite and co-requisite for this course that you've taken ME 101. So we're expected that you have this knowledge and these resources as you're going back and writing up your reports. So a little bit of course information for this lab and lecture. The lecture portion of this course is going to be online and asynchronous. I'll be posting the lecture slides and video presentations to Blackboard, and that will be our primary source of communication throughout the semester. The location for the actual labs, this is an in-person lab, and this is in the materials lab in VOTI 246. Now, if you have elected to take this as a fully remote course, I am offering virtual labs for those that have signed up for the virtual, completely online version of this course for the lab sections as well. If this is the case for you, I think there's only a couple students that elected for this, please contact me and I'll let you know how to get set up for that. For the lab section times, there's 6 different lab sections throughout the semester. These are going to be Monday, Wednesday, Tuesdays, and Thursdays, and it's going to be based upon which lab you signed up for. So please go back to your schedule, take a look, and see which section of these labs, AO1, AO2, AO4, AO6, AO7, or AO8 that you signed up for, and make sure that you attend the correct lab section corresponding with which course you signed up for that lab section. This is going to be extremely important this semester, especially due to the fact of the regulation for the number of students that we're allowed to have in the lab at one time, and I'll get into the details of that in a little bit. I'm Dr. Burns, and I will be teaching just the online lecture portion of this course. The actual labs will be run by the TAs, Brandon Gamble and Ryan Pringle, and they'll be announcing to you once you get into labs what their office hours are as well. Now, as I mentioned, Blackboard is going to be the primary source of communication, so I'm going to be using this for distribution of your lab handouts, your lecture notes, any of your assignments, quizzes, things of that nature will all be posted on Blackboard, and you guys will be submitting them back through Blackboard as well. So let's get into a little bit about the grading. So for this course here, there's going to be 3 major components to your grade. The bulk of your points are going to come from your laboratory reports. This is 72%. So this is 6 lab reports, 6 different labs that we're doing and turning in, 12% each. And there will be an adjustment based upon your peer review. So there'll be a midterm peer review and a final peer review. And this is to make sure that every member of your group is contributing. And this is your opportunity to let everybody know, me and the graders specifically, of everybody's contribution levels. The other portion, next portion of your grade is going to be a laboratory notebook. So we ask that you please keep a laboratory notebook throughout the semester. And what we'll be having you do is at the end, we'll have you scan in a couple of the key pages for this onto Blackboard, and that's how this portion of the grade for the laboratory notebook or your class participation, lab participation portion of the grade will be determined. Lastly, there will be a final exam. This will be 20% of your grade. This will be an online Blackboard, probably about 20 questions, multiple choice, all related to your readings on the lectures and the laboratory handouts. So I will be providing you some handouts, templates, and introductory lectures all through Blackboard that you guys can use to reference for how you write your lab reports. Any other questions, please visit my office hours or discuss with your TAs, either in the lab or during their office hours as well. We have some pretty good templates set out for you guys, so it should be pretty straightforward as far as what we're expecting for the format for these lab reports. So again, peer review, I'll briefly go over this again. is where you're going to review all your team members here. Any of the deficiencies that are noted here will be addressed. So if the peer review is not improved from the midterm to the final, 20% of the lab report grade will be removed. This is up for negotiation as well, so please just feel this is a way for you to express any concerns that you have for the contribution levels of your group members in a private setting between just me and you and the graders, so that we can adjust these correctly based upon everybody's performance and their review status within this peer review. So for your laboratory notebook, what we're going to be utilizing this for is to document your work along the way, any data that you collected, calculations, graphs, little notes. So you might say, okay, in this one here, we ended up moving the extensometer to a different location. We were a couple degrees under with the temperature for this collection of data. Things like that, just little notes and things that you did when you're collecting data, or abnormalities as you're setting things up in the lab. And these are going to be important to help you more than anything as you start writing up your labs. Again, final exam, 20 questions, multiple choice, all on Blackboard. Going to be the basic review of the engineering theory and techniques from the laboratory. So a lot of these questions are going to draw directly from my lecture slides and presentations throughout the semester. Office hours. I am personally going to have office hours for this course from 9 a.m. till 10 a.m. on Mondays. If you need any extra help outside of these, please feel free to contact me via Teams or email. Also, your TAs are a great resource as well. They'll be in the labs with you during your laboratory experiments, and they also will have office hours as well. Just a note, these are all going to be virtual office hours conducted through Microsoft Teams. So next thing I want to go over is our schedule for the semester here. So this has been posted to Blackboard as well, but I want to just take a little bit of time now and go through it with you. So I've broken this down into each of the weeks throughout the semester. You can see in this left-hand column over here, and it lets us know which week you're going to have a lecture, and which week you're going to have a lab, and what the topic of that week is going to be, and if there's anything due that week, it's listed over here. So this is a nice, organized presentation of everything you can expect to help keep your time management on track throughout the entire semester. So we can see this first week here of classes, there's going to be a lecture, but there's no lab. Second week, there's going to be a lecture, and there's going to be no lab as well. We can see the topic for this first week we're going to talk about here is going to be the introduction. And in week 2, we're going to talk about the first lab, part 1A. And then when we get to week 3 here, on the 15th, this is where we're going to have a lecture, but we're also going to have our first lab. And our first lab is going to be our photoelasticity lab 1A. Nothing due yet. So we can see as we come down here, this is the first thing that's due. Your lab report 1 will be due on 3/1. Then we can see your lab report 2, and then that's due. Then you have your midterm peer review due, 3, 4, so on and so forth. And we go all the way down so we can see when all of your labs are, when all of your lectures are, and due dates for everything. So this is clearly posted. This should remain fairly constant throughout the semester, but if there are things that come up, we'll address them and make adjustments, and it'll be posted to Blackboard as they happen. Now, as I mentioned, I'll be giving these lectures, and they're going to be online, asynchronous lectures once a week posted to Blackboard. So the purpose behind these lectures is to give you guys a little bit of the relevant background and your theory for the upcoming experiments that you'll be running in the lab with the TAs. So what theory should you remember from your previous courses? So I'm going to be highlighting some of the stuff you may have seen in earlier courses, not going through in extreme detail, because this is stuff that's going to be a little bit of a refresher for you and just remind you of things that you need to draw from. Because as you notice, there's no textbook for this course, so you're expected to be utilizing some of the textbooks from your previous courses. I'm going to be talking a little bit about the technology that you'll be using and how it works as far as the laboratory equipment goes, what measurements you should be taking throughout the labs for your data analysis, if there's any sources of errors, what those should be, and what calculations you should be completing, and a couple of the key equations associated with that. So that's kind of what you can expect from the lectures. It's just kind of an overview with the background theory and information that you'll need for the laboratories that you have coming up. So that's why the lectures will be done prior to that experiment in the lab. So now as far as the laboratories go, this is going to be a mandatory attendance. Now I know this semester is a little bit different in the fact that there is the option for remote learning. So anybody who has opted for that, again, please contact me privately, and we can make arrangements. I have virtual labs set up for all of these and data collection as well for all the labs, so you can still attend virtually and participate in the lab write-ups. For everybody else who has elected to be in person, your attendance is going to be mandatory, and you're going to be asked to bring your laboratory instructions with you. These are going to be, again, posted to Blackboard. I'll have those up for you in advance. Also bring your laboratory notebook. And reminder, this is something that will be graded at the end of the semester, so you'll need to scan in a copy of this and submit it to Blackboard at the end of the semester, so make sure you keep up to date with that. The other thing that we ask is please be ready for your lab sessions when you get there. Make sure that if you're in person, you get there on time, especially with the social distancing requirements. You'll have to make sure you're either in the laboratory or the remote viewing room, and make sure you switch correctly to be prepared. Also, please view all of my live lectures, look through and read through all the documentation before you come to lab sessions. That way you're well prepared, you know what you're doing, you won't waste time during the laboratory part trying to learn things for the labs that you should have seen in the lectures, and you can move quickly through the laboratories because these are very time intensive, so it's going to take quite a bit of time, especially switching back and forth between two groups with the lab and the remote viewing room. Now for your lab notebook, what I'd ask you to do is get a composition notebook here. This is for you to provide a detailed chronicle of everything that occurs during the laboratories. Please, on each page, make sure you label and date each entry related back to whatever experiment you're doing and portion of that experiment. Again, this is to help keep you organized so you can reference back to this as you start doing your lab reports. So the more neat and organized it is, the better it is to help you do that. Within this, you should include the theory from lecture notes and handouts. You say, okay, in lecture 2 on the 5th slide, I saw this relationship, this governing equation I'm going to use there, so you can quickly go back and utilize that when you're writing up your lab reports. What equipment was used, resolutions, short descriptions and drawings of your experimental setup, key procedural steps, data recorded, so what your data acquisition rate was, things like that. If there's any issues that went wrong, please note those for your lab report. Observations for what you saw happen, post-experimental data analysis and calculations, and if you want to either glue in or just hand sketch in a couple of graphs of what you think they should look like, or what you saw on some of the digital display outputs within the laboratory equipment. Another thing to know actually as you're doing this is it is important to keep the laboratory notebook, but also with technology, it would be nice as well if within this you took a lot of pictures as well of these laboratory setups, possible errors, descriptions of the equipment, so you can take a picture of the equipment and then put a description next to it. So some images would be great too, and those will be great to put into your lab reports. So let's talk a little bit about the lab write-ups. It's going to be 6 different labs, 6 different lab write-ups that you'll have due for the semester. So these reports are going to have due dates noted in the syllabus, course schedule, and on Blackboard. There'll be release dates and due dates for this. So there's no real reason for any of these to be late, and if they are late, you will lose points for it. So you're going to write up these reports as a group. You're going to assign roles, sections. Somebody may be doing the FEA analysis or the CAD drawing. Somebody might be doing the hand calculations. Somebody might be doing the actual write-up or the background and theory section. So whatever it is, make sure you assign your roles and sections to help divide and conquer the individual tasks for this lab write-up. Combine all of these sections together. Make sure it flows in a good manner. Double check each other's spelling, grammar, coherence. Check your units for your figures, your labeling, and your tables. Make sure you get it scanned in and posted up to Blackboard. Or if you're typing it out, just please submit it as a PDF. Usually works best, but Microsoft Word is also acceptable. And also make sure to note there's a peer review of the workload of the sharing of this workload. So at the end of your report, you can say, Johnny did this part, Sarah did this part, Joe did this part. Just so you know later on, if there is any issues when you do your peer evaluations, we can look back and see who was doing which portion of the lab write-up. So being that we are in a laboratory setting, safety becomes very, very important. There's a potential of getting injured within this. So please pay attention to any warnings, listen to the TAs, read through all the documentation before starting the experiment. There'll also be safety videos I have posted up to Blackboard as well. Please read through all of these before you attend your first laboratory. Another thing here in the lab, please don't bring any food or drinks in. Safety glasses when required. Make sure that you have closed-toed shoes, no sandals or open-toed shoes. Make sure if you have anything, longer hair ties, jewelry, things like that, they're tucked back or put away, not worn in the laboratory. And keep your cell phone usage to a minimum just so you're paying attention to each other and the equipment. So now what we're going to do is we're going to get into just a quick overview of each of the 6 laboratories that you're going to be going through. So the first laboratory you're going to have is Lab 1A and 1B, and this deals with photoelasticity. What we're going to be looking at specifically is some beam bending and strain visualization. Now within photoelasticity, some of the things you're going to be looking at within the lab the fringe constant determination. So there's a lot of documentation within my lecture and with all the supplemental material that I've uploaded to Blackboard for you as well. A portion of this that's going to be very important is your calibration of the equipment as you set it up. And that's going to be the case for all of these labs and experiments you're working on. And also utilizing the correct test equipment. Again, so I can't stress this enough, please read through the documentation, look through the lecture slides before coming to lab so you have a good understanding of how to utilize all of this. The laboratory TA will also be giving a brief lecture at the intro to the lab going over all of that and talking about the equipment as well. So lab 2, we're going to deal with lab 2 is beam deflection and free vibration. Some of the equipment that you're going to be utilizing within this lab is the strain gauges, your strain gauge amplifier, data acquisition equipment, and doing some spectrum analysis as well. So again, please read through all of the materials, become familiar with all of these, review back to some of your other courses that you've dealt with strain gauges in the past, how to apply these. Again, the TA will go over the details as well, but the more background information you have prior to going in, the more you're going to be able to get out of these laboratories. Lab 3, we're starting to deal with a pressurized cylinder. So this is going to be a pipe and pressure vessel analysis. So you can see here, this is the equipment that we're going to be utilizing here. We're going to have some strain gauge rosettes. You're going to need to learn how to use those or refresh yourself on how to use those and acquire data from them. And we're using Moore's circles and some principal stresses and strains for the data analysis. Now, as we get into lab 4 and 5 here, this is going to deal with heat treatment and hardening of some different material samples. So we're going to take a look at the ASTM standards for a geometry bar test, and we're going to utilize that within this laboratory for the experimental setup. The hardenability of steels by quenching, so we're dealing with some quenching relationships, equations, and calculations. We're also going to be talking about the Rockwell hardness testing, and we can see over here in this image here, our Rockwell hardness tester there that we're going to be utilizing on the samples. Now for the 5th lab here, this is going to be 2 parts, part A and B, and this is where we're going to be dealing with some tensile testing. So this is a really fun lab. We're going to be using an Instron machine that you can see up here. We have this right in the laboratory there for you guys. So we're going through, taking a look at some of the ASTM standards for tensile testing, look at a couple different material types here, 6061 aluminum, some 4031 steel, looking at the effects of quenching and tempering on the steel, and we're going to be comparing the results as you run the tension tests on those different samples. And lastly, we're going to be using a standing electron microscope after we've pulled these samples and cracked them to take a look at the individual cracks in those samples close up. So lab 6, what we're going to be dealing with here is fracture mechanics testing. So within this laboratory here, you can see some of the equipment that we'll be utilizing here. And this will be fatigue, crack propagation, looking at plane strain, fracture toughness, utilizing a couple different materials. So I want to take some time to discuss my plan for remote instruction this semester. So for this lab right here, Materials and Mechanics Lab, ME 124, the actual lecture will be fully online. So this portion of the course is going to be completely remote and asynchronous, and I'll be posting everything to Blackboard. Now, if you take a look at my Blackboard, I have a weekly module outline format. This is for all my courses, and I adjusted it for this laboratory lecture as well for you guys to keep things nice and neat and organized throughout the entire semester. So each of these modules is going to contain the weekly lecture slides, any quizzes, material, assignments, presentations, supplemental handouts are all going to be located on Blackboard for you guys to reference. So my objective is to provide you guys with enough options to learn this material effectively, but not overwhelm you by just dumping a ton of stuff. So I want to keep it neat and organized. So that's what this module template will allow me to do, is keep this stuff neat and organized and easy for you guys to follow along with. That way you're spending your time learning the actual material and content rather than trying to navigate through some overwhelming amount of material just dumped onto a Blackboard forum. I will also be available via Teams for any remote face-to-face questions that you have throughout the semester. And also remember, the TAs will also have office hours as well. And the laboratory times, the TAs will be there so you can discuss with them anything in an actual face-to-face scenario as well. So one thing I want to note with this plan for instruction is this is a whole new area for all of us, both on the teaching and the learning side with this remote instruction. So please, if you have any questions, please reach out to me, reach out to the TAs, send me a message on Teams, send me an email, and let me know, hey, I'm having a hard time hearing the audio, or this is not quite how I'd like to see it, or could you please put up some more of this? So anything that you need, any constructive criticism, anything that is working well and you like, please give us, me and the TAs, some feedback so that we can make the adjustments for you guys in order to give you the best possible course and presentation of the materials that we can. Now for the laboratory portion of this course, there's going to be 6 different lab sections, and 10 students have signed up for each of these sections. But with the requirements, with COVID and the pandemic, we're only allowed to have a total of 6 people in the lab at a time, one being the TA, the other being 5 students. So we need to break these groups of 10 down into 2 teams of 5. So please take a look at what section of the lab you signed up for, and you'll be breaking this down into 2 teams of 5. So this will be your first assignment that I've already posted on Blackboard, where you guys will come up with a list, decide amongst yourself what the 2 teams of 5 will be, and you'll be submitting that through Blackboard as an assignment. So in total, there will be 12 teams of 5 once we break these 6 teams down into 2 teams of 5 each. And what this will be is that each of these 12 teams will each be responsible to turn in 1 final report per group. So now for the actual lab sessions, these are going to be located in VOTI 246, and they will be in person unless you have opted for the fully remote option for this course. And again, if you've done that, please contact me. This room only allows for 6 occupants max. So the plan is to have 1 TA in the lab and then 5 of the total 10 students. So this is the reason we need to break into those 2 teams of 5 from the 10 people in each of these lab sections. So 5 of these students will start in the lab section at the beginning of the lab, while the other 5 students will be outside in the remote viewing room, which is attached, room 223 in VOTI building, watching the broadcast from their laptops inside the lab. So each lab section is going to be divided into these 2 teams of 5. So again, breaking it down, 12 teams total, 5 students each for all 6 lab sections. So summary, the lab will take place 246 VOTI. The viewing room is attached in 223 VOTI. Now here's what I am encouraging you guys to do. Within these 2 groups of 5 for each lab, I'm encouraging students to alternate between the remote viewing room and the lab room. So doing this following social distance protocol and safety requirements, please feel free to make changes throughout the lab where one or a couple of students from one group are in there running the experiments. Then you guys can switch partway through and they can go to the remote viewing room, and the students that were in the remote viewing room can come into the laboratory, run some experiments while the other students watch remotely. So please take turns on the equipment in this manner, taking pictures and getting that hands-on experience. So I don't want anybody who feels comfortable and wants that hands-on experience to be stuck in the remote viewing lab for the whole semester. So this is why within each lab, I'm encouraging you to alternate following safety protocols. And also what I'm encouraging you to do is the groups are going to be alternating weekly for each of these labs, and which group starts in person and which group starts in the remote viewing room at the beginning of the lab. So over the break, I went out and spec'd out some high-end, good quality video cameras and audio systems for this lab. I really wanted to give everybody who's in the remote viewing room or taking this as a remote course from a remote location at home or in their dorm room as realistic an experience as possible. So what I decided to do was get 2 really nice camera setups that are specifically designed for Microsoft Teams. There'll be 2 locations of these cameras. One is going to be showing the whole view of the entire laboratory, so you can see all the students, all the equipment, how things are moving and flowing through the lab and linked together. And the other one is going to be on a remote cart on a tripod that the TA will be moving around from each portion of the experiment, just getting a close-up, seeing all the data being collected, the experimental setup, how the machines are calibrated, all that will be on the close-up camera. So these two cameras will be wired in through Microsoft Teams for each lab section, whereas the students in the remote viewing room or at home will have their laptops hooked up and will be able to pin whatever camera they want. So if you want to look at the whole view of the room and take a look at it, okay, here's what's going on. Then all of a sudden, oh wait, what's going on close up? Okay, let me switch over and pin the camera that the TA has aimed right on the experimental setup. So there will be one Teams meeting set up, and both of these new cameras will be connected with video. One will have audio, and one will be muted just to eliminate the feedback. You only have audio from one of these there, so make sure on your end of Teams you have that set up correctly so you can hear the audio. The students that are start remote or are remote currently at that time in the VOTI 223 room will be connecting from their laptops, and again, need to just pin one or both of the videos, depending on what you want, if you want to leave them both up at the same time or just want to zoom in on one. The TA will try to give you guys a little bit of a heads up as to when the views are going to change. You'll be able to see that live on the overview camera of when he moves the close-up camera there. And just a little bit of summary on what equipment I'm using within this here. And the fact that both of these will be streaming simultaneously live on Teams throughout the entire laboratory. Now what we have to get into here is COVID rules for the lab. So all the students in the lab, please follow the guidelines specified in the Golden Green Promise. Wear your PPE masks at all times. Only one student in the group can touch the equipment at a time. The TA will then wipe everything down before another student can touch anything. You're asked to maintain a minimum 6 foot distance between all the students and the TA while you're in the lab. And a thing to note, please follow this. It is the whole laboratory, as we just talked about, will be recorded on camera, so everybody will be able to see if you're not following protocol. So please, please, please follow the protocol specified in the Golden Green Promise. Any unnecessary safety precautions will be taken when students are alternating between the lab and the remote viewing room back and forth. So right now I want to take a minute to address the students that have chosen the fully online or at-home option for this course. So these students will have the ability to tune into one of the lab sessions through Microsoft Teams and participate as an extra member of the group. So these labs experiments are going to be broadcast live on Teams. I'll also have virtual labs for the remote students as well. These virtual labs will be posted on Blackboard along with the data and images from the lab. Now each team member is expected to still contribute to the data reduction, analysis, and report writing. So this is going to be viewed as their participation portion of the lab. So even though you can't be in there in person running the labs and collecting the data, you can still be watching your other teammates do that live, and you can be participating in all of this data reduction, analysis, and writing for the actual report. Now, for these fully remote lab sections, the students can watch the transmission via the live broadcast on Teams, or if that doesn't work, you can opt for the virtual lab videos that I have posted on Blackboard. Now, a thing to note with this is if the rest of your team is doing this based off the data they're doing live on the synchronous version that you could watch on Teams, then the data that you have from the virtual labs is going to be a different set of data than what the rest of your group is using. So please communicate with your groups and make sure that you're using the correct data set for any of the analysis, data reduction, and report writing. So again, even though you're not able to do the experiments in person, you can help with the data analysis and reduction and join the lab team, participate in observing experiments and the report writing. And the thing to note I really want to mention here is that you can also join on Teams. So you can still come in, view this synchronously with your lab and your teammates. I really encourage you to talk with your teammates. Even if it's not during this lab section, please set up a time so that you guys can all remotely work together. And this goes for the students in person and the at-home students as well. This is a great opportunity to utilize some of these resources that we have now with Microsoft Teams to get together virtually as a group, talk about your lab write-ups, share data, all that stuff there, so you can still work together and collaborate even if you need to be remote.